Okay, so for the last section in this chapter, we're going to talk about the double and half angle formulas. Our essential question hasn't changed. It's still how can I find the exact value of trig functions using values that I know from the special angles in the unit circle. Okay, so this is the same as last notes. When we're asked to find the exact value of a trig function that's not on the unit circle, we can use some formulas to kind of help us out. Last section, we looked at the sum and difference formulas. Now we're looking at the double and the half angle formulas. Okay, so when do we even want to use double or half angle formulas? Well, if we're given an angle that's not on the unit circle, but it's a multiple of an angle on the unit circle. So let's say I had like 15 degrees. Find sine of 15 degrees. Well, that's not on the unit circle, but 30 degrees is, right? And 15 is half of 30. So I could use a half angle formula to figure out what sine of 15 degrees is. So let's use the example that we had before. So it says, find the exact value of sine of 105 degrees. We already used the sum and difference formulas to evaluate this, but let's see if there's another formula we can use. So because 105 is not on the unit circle, we can use the fact that, well, it's not on the unit circle, but 210 is, and it's half of a known angle on the unit circle. So I can use the half angle formulas to say, well, I know that my angle is half of one of the special angles. Let's evaluate. Okay. So here's our formulas. We actually are not, this is the power reducing formula. We're actually not going to use that formula. So double angle, if I have sine of a 2 times an angle that's on the unit circle. So maybe I wanted to find, I don't know, trying to think of a double that's not already there. But if I wanted to find sine of double of an angle, I can use this formula. Same with cosine. Cosine actually has 3 different formulas that we get to pick. And really, we get to pick unless we're given certain information. If we're looking for cosine of 2 theta, but we're only given information about sine of theta, we'd have to use this formula. But we'll go through some examples so you can kind of see. And then we have the double angle formula for tan. All the half angle formulas are here. So like my example, if I was asked for sine of 15 degrees, because 15 is 30 divided by 2, we could say, well, let's find cosine of 30 and evaluate. Okay. And the plus or minus signs just depend on where you are in the unit circle or on the XY plane. So just make sure you know where you are on the XY plane. We actually not going to use those 2 formulas. So we have our half angle formula for sine, cosine, and tangent. We have our double angle formulas for sine, cosine, and tangent. All right, so let's go back to our example. Sine of 105 degrees. So like we said, 105 is the same thing as 210 divided by 2. So sometimes it's kind of like, how would I know that? Did that number just pop out of the air? Sometimes you can double and you can figure it out in your head. But if not, we could always take the angle that we're given, which is obviously not on the unit circle, and set it equal to either 2 theta, if we think we're going to use a double angle formula, or set it equal to theta over 2. Okay. So if I set it equal to theta over 2 and just solve for theta, I'd have to multiply by 2 on both sides. All right, so I get 210 equals theta. So when I solve for theta, if I get an angle that is on the unit circle, I know that, okay, great, I can use that formula. All right, if I would have used pi over 2 and got something like 212, something that's not on the unit circle, then I say, okay, well, that's not on the unit circle either. I can't use the half angle formula. Okay, so I told you 210, but if you weren't quite sure, just set your angle equal to pi over 2 or 2 pi and just solve for theta. Theta over 2 or 2 theta, and just solve for theta. See if that theta is on the unit circle. All right, so ours is, so I'm going to rewrite this as sine of 210 divided by 2, because that is equivalent to 105, right? And now I can say, well, my theta, I'm going to move this down a bit. My theta is 210. Let me plug it into the formula here. So I'm going to say plus or minus square root of 1 minus cosine of 210 divided by 2. Right? And then if I think about 210, where is 210 on the unit circle? Because I need to find cosine of it, and I need to figure out the sign, positive or negative. of my trig ratio. So 210 is over here in quadrant 3. Put it like there. All right, so you look at your unit circle, you say, oh, there's 210. The point there would be negative root 3 over 2, comma 1, comma negative 1/2, sorry. And if I look here, in this quadrant, I'm in quadrant 3, sine is also negative, right? So I'm not looking for sine of 210. I'm looking for sine of 210 divided by 2. But I know, oh, sorry. I know sine and cosine are negative here. We'll talk about the sine of this guy in a minute. So I have plus or minus, I'll leave that for now. 1 minus cosine at 210 is negative root 3 over 2. So I'm going to put negative root 3 over 2 divided by 2. Now it's just my job to kind of simplify, do a little bit of algebra and simplify. Okay. So I have square root of 1 minus, I'm going to put plus root 3 over 2. All of that's divided by 2. Now you can kind of simplify in your own way, but I'm just going to make sure that I have a common denominator here on the numerator. So my denominator is 1 and 2, so my common denominator would be 2. All right, so I'm going to rewrite this as 2 over 2 plus root 3 over 2. This guy on the denominator, the real denominator here, this guy didn't change, so it's still over 2. All right, and then I keep going and simplify, and I have 2 plus root 3 over 2. All of that is over 2 still. And all of this is under the square root. Now that I have one fraction on the numerator divided by another fraction, I can say, well, this is the same thing as multiplying by the reciprocal, 1/2. So I really have square root of 2 plus root 3 over 4, which I can't really do much on the numerator because this is not a perfect square, but 4 is. So I can rewrite this as square root of 2 plus root 3 over square root of 4 is 2. Now, I dropped my plus or minus, but ultimately we have to figure out, should this be a positive or negative? And we go back and look at, well, what was I finding? I was finding the value of sine of 105, right? Here's 180. 105 is somewhere up here, right? We don't necessarily know exactly where, but it's somewhere up here. Sine in quadrant 2 is positive, right? Sine is our y values. Y is positive here, so I know my answer needs to be a positive. So this plus or minus doesn't give us two options. It means you check what the sign should be based on the quadrant that you're in. So my answer is actually positive, square root of 2 plus square root of 3. Square root of 2 plus root 3 over 2. And I'll leave it as positive. You can put a little positive sign if you need to, but it's positive there. Bring this down a bit. All right.